Hello, precalculus class. Today we're going to use the inverse matrix in order to solve the system of equations. So for this warm-up, go ahead and multiply these two 2x2 matrices. Pause the video now. Okay, here's your result. It turns out that the result is the identity matrix right here. What you had was a matrix times its inverse. All right, after I showed you how to find an inverse matrix by hand on a 2x2 and a 3x3 using row operations, then I told you how you could do it in the calculator, and even better, there's a shortcut to do it by hand for a 2x2. This shortcut is only good for a 2x2 matrix. What you do is you're given your matrix and you rearrange it, so you switch the order of this diagonal. You leave these in place, but you make them both change the sign. And then you divide each term by the determinant of matrix A, and the result is the inverse matrix. We can test this out with the problem from the last page. So the matrix we were looking at on the last page was this, -2, -9, 2, 8. So let's go ahead and find, if this is matrix A, what its inverse is, and then you can check, or we can check with what we know it to be. So first thing I have to do is find the determinant. So that is -16 minus -18, so that is 2. So it's going to be this matrix divided by 2. And then what we're going to do is switch the order of this diagonal and then leave the order of the second diagonal, but change each sign. And let's see what happens when we do that scalar division. We end up with 8/2, which is 4, 9 halves, -2/2 is -1, -2/2 is -1. And that was the inverse matrix that you saw from the other page. These are both -1s. So that is just a quick example of how it works. You can either do it this way or do it the long way using row operations if I ask you to do it by hand. Okay, so we are going to take this system of equations. We have 3 equations and 3 unknown variables, x, y, and z, and we're going to solve it using this formula here. So what this says is matrix A times matrix X equals B. If that's true, then X equals the inverse of A times B. Think about it this way. Let me just write this out. If I take A times X equals B, and I multiply both sides by the inverse, right? If you do something on one side, you need to do it on the other. Order matters though with matrices, so I'm going to do it like this. And we know from the property of matrices, anytime you multiply a matrix times its inverse, you're going to get the identity. And we know that any matrix times its identity returns the matrix. So that shows you why this leads to this. But what we're going to do is take a system of equations and write it as a system of matrices. So A becomes the coefficients. So that's 1, 0, 2. That's your x coefficient. The y coefficient is -1, -1, 2. And the z coefficient is 2, 3, 1. Make sure they're all on the left side of the equations. That's your A matrix. Your X matrix is the variables x, y, and z. And your B matrix is your solutions 1, -2, and -1. So we want to solve for the X matrix. All right, and what we're going to do, just double check real quick. This is a 3x3 times a 3x1, returning a 3x1. That makes sense. And if you take each row times each column, it equals this. So 1x minus 1y plus 2z equals 1 is just rewriting this here. Okay, so that's the first thing you do. But now it says to solve this is all you have to do is take the inverse of A times B. So that's what we're going to do. So now I need to show that X will end up equaling the inverse of A times B. So I need to go and find the inverse of A. Well, the inverse of A will be a 3 by 3. I think for this purposes, I'll use the calculator. I'll enter matrix A under second matrix, edit, 3 by 3, enter all those values. Then I will go ahead and choose matrix A with the second matrix name menu. And then use the inverse key and hit enter. And then I like to put it in fractions, so math frac, and hit enter, and then you get the matrix. So it is, hopefully you've done your calculator as well, 7/9, -2/3, -2/9. This happens to be the same example we did in the lesson from before when we did it by hand. All right, so here is your matrix A. This is, or your inverse of A. This is a 3 by 3. Now we're going to multiply it by B, which is a 3 by 1. So your result, 3 by 3 times 3 by 1 is going to be a 3 by 1 matrix, which is going to be the values of X, Y, and Z for that system. So you can do this by hand, right? Remember, it's this row by this column. So you're going to have 7/9 minus 10/9 minus 1/9, and you get 16/9 for X. Then you'll do the next row, -2/3 minus 2/3 minus 1/3, and you get -5/3. And the last, -2/9 minus 8/9 minus 1/9 is minus 11/9. Now, feel free to also use the calculator to multiply the matrices. You can take A inverse times and then store in matrix B as a 3 by 1, and then you just multiply them together using the multiplication key, and you will get your answer. So that is how you can use inverse matrices as long as you have a non-singular matrix in order to solve a system of equations. Okay, we're going to end this lesson with just 2 examples that we're going to use inverse matrices in order to solve. The first one is this word problem here. Take a moment and read it over. Pause the video. Now we need to assign variables and set up a system of equations. So the question is, how much of each type is needed to create the blend? So we have, let's see, 85 pounds of new coffee, and it's going to be $8.60 a pound, and it's a blend of the $6 per pound coffee and the $9.25 per pound coffee. So I'm going to say X equals the $6 per pound coffee, and what X is the amount of pounds. Y is the $9.25 pound coffee, number of pounds. All right, so we have a system of equations. So we know we want to have 85 pounds of our blend. So that means X plus Y equals 85 pounds. And the blend needs to work out to $8.60 per pound. So that means $6 times every pound of X plus $9.25 times every pound of Y needs to equal $8.60 times every pound of the blend, which we know is 85 pounds. All right, there's our system of equations. So we're going to set this up as a matrix equation. And we know we have the variable X is 1 and 6 coefficients. The variable Y is 1 and 9.25. And then our variable coefficient, we decided we'd use X and Y. and it equals our solution. So we have 85, and then we have the product of 85 and 860, which is 731. So in order to solve this, think about it as AX equals B. We're going to have X equals inverse of A times B. So my X matrix, which is XY, equals my inverse matrix, which we just learned a little trick where we can take these values, switch the direction, divide them by the determinant, or you can use your calculator as well. And likewise, I'd also take 9 1/4 and turn it into 9 1/4 so that I have fractions. So here's your inverse. It's not very pretty. 37/13, negative 24/13, negative 4/13, and 4/13. And that's going to be multiplied by the solution matrix of 85, 731. So now you would take each row times each column, and we'll end up with X and Y equals 17 and 68. So that means there's 17 pounds of $6 coffee and 68 pounds of 9 1/4 coffee to make the blend that they want. So remember, you were doing 37/13 times 85 plus negative 4/13 times 731. That gets you the 17. And then negative 24/13 times 85 plus 4/13 times 731 gets you the 68. And you can do that by hand like we just did, or using the calculator matrix menu. Here's our last example. Go ahead and pause the video, read through it, and try to assign variables and set up the equations, and then set up the matrix equation. So here you have, I always look at the question at the end, what is the cost of each item? So I assigned variables for P is the cost of prime rib, S is the cost of a side, and R is the cost of a roll. And then we have Jackie's equation here. Jackie ordered a prime rib, 2 side dishes, and a roll, and her cost was $36. Ted ordered a prime rib, 3 side dishes, and 2 rolls. Prime rib, 3 side dishes, 2 rolls. His cost was $44. And so we only have 2 equations there, but it says the prime rib is 3 times than a side dish, more expensive. So the prime rib is 3 times the cost of a side dish. But you can't leave it like that. You need to have the variables on the same side. So I subtract the 3s and it equals 0. Then we can take that system of equations and set it up as a matrix equation. So think about this as matrix A times matrix X equals matrix B. And that's the coefficient times the variables equals the solution side. And that can then be written as X will equal the inverse of A times B. So X PSR will equal the inverse of A times the B matrix, which is 36, 44, 0. Why don't you pause the video now, go find the inverse matrix, and then solve for P, S, and R by doing this multiplication. Pause the video now. Okay, so here is your inverse matrix. I used the calculator to find it. I just went ahead and entered this matrix in A. Then I chose A, used my inverse symbol and hit enter, and then math frac so I could see it in fractions. Then I have to take each row times each column one at a time. This first row times column is 21, the next row times column is 7, and the last row times column is 1. So that means we have answered our question. Prime rib is $21. A side dish costs $7, and a roll costs $1. Well, hopefully the restaurant doesn't charge for every roll, but there are restaurants out there that will charge you separate for your side dish from your prime rib. All right, so that is your answer. And we are done with inverse matrices. Go ahead and try your homework assignment.